Hi class, in today's lesson we're still studying probability, and this is our last lesson for this chapter. And for this topic we're going to be looking at the lesson of independent events. So there's two terms that you need to be familiar with. The first term is a compound event. Basically what a compound event is when two or more events take place. A good example of that would be like, let's suppose that you've got you've got a set of dice and then you roll it 3 times. So that would be an example. That would be an example of a compound event because you're doing 3 different rolls, and so those are 3 different events that are happening. Now, an independent event is when the outcome of an event does not affect the outcome of other events. So rolling dice is also another example of events that are independent with each other because the first roll doesn't have an effect on what the second roll, the third roll, the fourth roll are going to be. Another good example of that would be, well, let's suppose you've got like a bag of marbles of different colors. Let's suppose you randomly pick a marble out of the bag, then you place it back into the bag, and then you randomly pick another marble out of the bag. So because we replace the marble back, it's not going to have an effect on the results or the outcomes of other events in the future. So how do we calculate independent event probability? It's actually really easy to do. So if you recall the notation that we used earlier in the chapter on how we represent probability, this is an example of a compound event here. So the probability of the first event, then the second event happening, is equal to the product, or the probability of the first event times the probability of the second event. So all we're going to do is take each probability event that happens and then multiply them together to find the total possible probability of the outcome of those compound events happening with each other. Let's take a look at this example that we have down below. There are 6 cubes in a bag. We've got 4 cubes that are red and 2 cubes that are blue. You draw a cube from the bag, you put it back, and then you draw another cube. Find the probability of drawing a red cube the first time, then a blue cube the second time. So let's think about what's taking place here. So the first event, we're figuring out the probability of drawing a red cube the first time, then the probability of drawing a blue cube. And so we have 2 different probability events that we're calculating. So the probability of drawing a red cube and then the probability of drawing a blue cube, which is going to be, we're going to multiply the results of those 2 probabilities together. So let's think about our details in this word problem. There are 6 total cubes in the bag. 4 of those cubes are red and 2 of those cubes are blue. So think about how you would set up your probabilities for both of these situations. The probability of choosing a red will be 4 out of 6. You see that? So we've got 4 out of 6 for our first probability, and then the probability of choosing a blue will be 2 out of 6. There you go. Now, of course, one thing you can do to make the math a little easier on you before you multiply, if you would like, you can reduce both of these ratios down and then multiply them together. And as a matter of fact, let's do that because that'll just make our world a whole lot easier. So 4 over 6 is the same thing as 2/3. 2 over 6 is the same thing as 1/3. So let's use those two ratios and multiply them together just to make our math a whole lot easier. So now 2 times 1 is 2 and 3 times 3 is 9. So the probability of those independent events of drawing a red cube and a blue cube is a 2 out of 9 chance that it will happen. Let's look at another example. Here's our second example. You guess at random the answers of 4 true or false questions. And what is the probability that all 4 questions are correct? So let's think about this. We got 4 different questions. Each question does not have a direct effect on the outcome of the other. And all 4 questions are true or false questions, meaning that there are 2 possible answers that could work for each one of those questions. It's either going to be true or false. So it's a total of 4 questions. So the first question has a 1 out of 2 chance of getting correct. The second question has that same probability. The third question, same probability. And the fourth question, that same probability. So what is the probability that all 4 answers are correct? Well, we multiply together our 4 probabilities for the 4 separate questions to determine our outcome. Well, 1 times 1 times 1 times 1 is 1 on the top. 2 times 2, well, that's 4. 4 times 2 is 8. 8 times 2 is 16. So our probability that answering all 4 questions correct for the true-false problems is a 1 out of 16 chance that it will happen.